Howdy tubers, welcome back to the Zach Life. So this episode is going to be all about the generator. Now if you watched my previous videos, I have got a previous video about designing it, putting it together. It's a 353 two-stroke Detroit. It's got a 270 amp 24 volt alternator that'll be used to charge a battery bank. We'll kind of go over some of that in this video, and there's some previous. If you'd like to see me build it, you can watch a previous video. In this video, it's installed. We're going to hook it up. We're going to put fuel in the tanks, hook the fuel up to it, the electrical, the air, get the control systems, the PLC. We're going to get all that done, and we're going to be effectively finished with the generator. Now, please keep in mind, as I've said previous, there's about 4 videos running simultaneously, and the videos I put out are not necessarily always in chronological order. I try to group the videos together in different systems or what have you, to make it easier for someone that wants to build one or has some questions about my coach. You can look up, the generators, not just the date. Anyway, if you're new to my channel, go check out the old videos. You can see the coach go from a literal pile of steel here in the shop to where we're at. And if you want to see it go from the point we're at today to finished, hit the subscribe button and the bell. We appreciate it. This is the little coolant reservoir for the generator. I call these a degas bottle. That's what Ford calls it. This is a pressurized, where it actually flows coolant through here under pressure. It's not just a puke can. Got my little gauge pod here, come up pretty good. I got it in the this other bracket. I want to weld these in there and rattle can them black. We'll catch you when the paint's dry. So let's do a quick recap here of what's going on. I've got all these cables, all of these cables and hoses, except this one. Go over here and come up out of the floor to all the control junk over there. So we've got these 2 large cables here. These will be the cables that hook to the alternator. This is a 300 amp 24 volt alternator. These cables go up there where I just showed you, and then they'll go through a battery monitoring system that'll give you like a percentage of battery charge. From there they'll either go to the inverter or they'll go to the battery bank. It's going to have 12 T105s wired in 4 sets of series, or excuse me, 3 sets of 4 batteries. Each set will be in series for 24 volts. That'll give you the power to basically have a 5,000 watt inverter that you can run off your batteries overnight, or you can start this generator up and let the generator idle, charge your batteries, and 300 amps at 24 volts is 7,500 watts or something like that, 7,000. They give you plenty of power to run a couple of air conditioners with just this generator idling. If you need more than that, you'll have to take it to high speed. We'll explain how I'm going to control the speed of it all later. These are the ones that carry the current from the alternator to the battery bank, so to speak, 24 volts. This is a sort of an umbilical. It's, I don't know if you can see it, it's probably, I think it was 27 wires and an SOW cable. He goes over to that big junction box and we'll break out there, put a PLC in it, programmable logic controller, to monitor oil pressure and all that kind of stuff. Excuse me. And have not an auto start, but like where you can't engage a starter if the engine's running, that kind of stuff. This cable here is also a 24 volt cable. This goes all the way up under and through the woods into Grandma's house where the battery box for the truck is. And this is the 24 volts from the starter, or from the cranking batteries, excuse me, of the semi. And the reason I did that, the reason I'm going to start this off the truck batteries and not off this cable here, is because I was afraid that when you engage the starter, it'll pull so high current that it'll pull a voltage down on the deep cycle battery bank enough that it would trip out the inverter, especially if the batteries are low. Alright, I got some ground cables made up. I'm going to put them in. One goes framed to the starter, and then it goes a frame to the block. So I got these 2 little air cylinders. They're going to be the mechanism, along with a pneumatic solenoid, pneumatic valve, to kill the run stop position and the idle high speed position. this 2 cylinders, I'm going to take a couple of bolts out of the head of this compressor and mount this these 2 ends of this cylinder with a little bracket or something, and I can drill a hole and run this heim joint through it, and then use 2 nuts on this heim joint to move it back and forth to set the fine-tune adjustment. So I think you got an idea of what I got going here. I'm going to mount the other one tomorrow and run the hoses to it. Alright, we're back out here. I'm going to run out of daylight pretty quick. So, alright, so this goes right up in here. Alright, so that goes right there. Now, before y'all call it, any of y'all call me an idiot, I know that that's going to be impossible to put coolant in. And it's funny because this is, you know, I designed this coach for years, and this was something that probably more than 3 years ago on my CAD program, you know, drawing out where all this stuff fits and how this, you know, measuring this generator. And this was a problem that I thought about, and I came up with a solution for it years ago. I don't know, it's kind of funny. It's just like I remember in my head laying in bed, you know, designing how this was going to have coolant put in it. And here I am years later, and I'm actually going to implement it. I couldn't get that out. Here's a patented Dillard motor coach Detroit generator coolant fillet doohickey. See, that'll actually make that really easy. Anyway, I just think that's cool because I remember laying in bed thinking about how I could alleviate that problem, because this reservoir's got to be higher than the engine and all, and I knew it would have to be, you know, right up at the top of the of this door. I think that's neat. So I'd like to talk about these gauges here a little bit. These are made by Murphy. Murphy was a company known way back when to make sort of semi-automation equipment like pressure switches and variable float, you know, whatever, just industrial equipment to control things, you know, engines, whatever. Anyway, this is a really simple but ingenious design. It's got a wire here that comes out the back of the switch that is connected to this external apparatus here. Now, how this works is the actual pointer needle is grounded through the case and through the capillary tube. And if it comes over and makes contact, I know this is out of focus here, if it comes over and makes contact with this little pin, it grounds this wire. And this was used often in engines and stuff that ran out in the field, you know, that didn't have people to monitor them. Anyway, you can adjust the point this makes contact by sticking that's actually an Allen head. I know it's not focused and doesn't look like it, but you can simply move this around left or right and change the temperature that it will shut it down. This is a liquid filled, oil filled gauge, and the switch mechanism is internal. It doesn't work like this one. This is a more expensive, higher end one, but basically works the same. It's got 2 screws on the back where you hook a couple of wires up to. Anyway, I'm going to connect these together. They're going back to a PLC that we'll go over later, probably in a different video I'll talk about, but they're going to be what the emergency shutdown system is if you're not paying attention to the gauges and the engine overheats or loses oil pressure, whatever. So I've got a couple more things here to mount. I got a junction box that's going to go right here. Get in there and weld it down. And then I've got this little bitty air tank. Problem with air is when you start something up, you don't have it. It takes a minute to build it. And so I'm going to mount this little bitty air tank in here. We can't really see where it's going, but I'll show you inside. And the air compressor on here will pump and air this tank up. Now it should be able to air up this tank to, you know, 40 or 50 pounds. I would guess within 15 or 20 seconds. I just made that number up. And that'll give the ability of, once you start this generator, to kill it relatively quickly, because it'll build up air pressure relatively quickly. And there'd be a problem if you started it and it took 5 minutes to get up enough air to shut itself down. So anyway, the compressor is going to pump into this tank. I want to install this valve. This is a back pressure regulator. The valve is actually going to go up on the truck, but basically when you start this thing up, it'll air this tank up to 80 psi, at which point this starts opening, and it will relieve the pressure above 80 psi and allow it to go into the tanks of the main truck, where you can air up a tire, or if you just need to air the truck up, or whatever you need to do. Air cylinders. Now I was going to build a nice little fancy spacer, but that little nut there just fit perfect, and I think it's just probably what's going to stay. So we'll quickly go over the air system. So obviously this here is a compressor driven off the camshaft. It pumps through this into this small tank. Out of this tank on the back here is the air line that goes up there. The line out of the side comes over to this called a governor. And what this does is, when air pressure reaches 125 psi on this line, or the tank, it sends pressure through this Stratoflex hose down to the compressor. And you can't see it, and don't worry about looking for it, but on the intake valves of the compressor has got small little air cylinders, and this hose applies those air cylinders to hold the intake valves of the compressor open, so the compressor quits pumping. And then when the pressure falls back down to like 85 pounds or 90, it relieves the pressure in this line out this vent, and the thing starts compressing again. You can't see, but out of the air tank that's on the generator, this hose runs out the bottom. And I've got this little tank drain. This is going to be welded right inside the frame, so that this cable sort of dangles down like that. And you simply pull sideways on the valve in any direction, and it opens. And so you'll be able just to walk up, grab this cable that's dangling, pull out on it, and drain the oil and condensate out of the tanks. Alright, so I'm working on the exhaust. Here's what I got: a couple of 90s, nice little chrome tip. Working on the exhaust and the fuel lines. There's probably not much I'll be able to video, but let's knock it out. I'm gonna have to go knock a big dent in this to clear the cross member for the actual generator frame. I don't think it'll hurt the exhaust flow. This engine just won't be loaded enough to matter. Well, what do you think? I like the exhaust. I kicked it forward because the crap hose hangs right there, which is kind of farther back, right there. And if I brought this straight out, it'd have been pretty close to it. That'd keep it from melting it. Alright, I'm fixing to install the fuel sending unit. The fuel tank's right underneath our feet here. I'm just going to hole saw a hole in this wood. I think I'll put it right here, and then into the fuel tank, and we'll mount it right in the fuel tank. Now this will be underneath the water tank, but it shouldn't matter. I was really hoping that plug would stick into the hole saw. Of course it didn't. It fell down in there. I want to get a magnet and fish that out, and kind of run a magnet around at the bottom of the tank to get any crap that's fell in it. And then I'm going to put some fuel in the tank and set this in there and adjust it with an ohm meter, so that E is roughly 45 gallons of fuel, which is about the point that the generator will run out of fuel. The generator will run out before the truck. All right, I'm gonna put 45 gallons of fuel in it, and I'll be right back. Buying some fuel. I'm gonna get about 60 gallons of fuel. Hopefully that'll be enough to get it off the E needle, and I can set the sending unit. I had to get a cheater out to get my fuel cap broke loose. I was a little bit of an overachiever when I first put it in. There we go. Oh goodness. Even got a nice place there to store it while you're putting fuel in it. Well, there's about the first gallon. Is it running out anywhere? Nothing yet. Well, no leaks this morning. There's my... Alright, I've got this thing calibrated. It's got a few bends and tweaks in it, as you can see. I want to show you what I did here. I have taken and bent and took a soldering iron and melted a chunk out of this plastic and bent this stop so it actually goes farther down than it's designed to go. It's got enough of the wire round variable resistor in here that it still is on the resistor, but at this point it actually shows empty under E on the gauge, and I think that'll be kind of handy because right on E will be set up at the point that the generator dies, but there's still 35 gallons of fuel in here, and if somehow or another you let the generator run until you run out of fuel, it'll kind of give you an idea of that last reserve. Alright, so like 2 months later, welcome back to this video. So, we'll give you a quick update, sort of what's happened off camera and where we're at. So I've got the PLC all hooked up, all the electronics, the electrical stuff we've started. It's hooked up enough that this thing will start and run. I've got a set of switches here, probably off camera you can't see, that go to the PLC, and then the PLC can control the starter and all the air system. Okay, amongst this rat's nest, up here's the PLC you can see running. I've kind of grouped some of these wires out and started putting the stuff together I needed to make the generator run. Here's the two valves. The two valves that control these two air cylinders. Of course, I've got, we put fuel in the tank a couple of months ago, and I've got the fuel lines hooked up to the generator. I did actually try to start it. I just cranked it over once and it started and died. It's on air. But I need to change the oil in it. It's got like a 5W30 oil in it, which is way too thin, but I like to put a thin oil in a motor when you first put it together in case you've got any trash in a crank or anything, because you have high oil flow with cold oil to help clear any kind of crap that you got in the bearings or anything else. Anyway, we're going to change the oil in it. I've got this as sort of like a little industrial dryer vent, stainless. It's going to go right here. We're fixing to put it in. I've started bending this housing of this blower so I can take a short stub of pipe, stick up here and sort of weld to it every place it touches, so I'll have something to clamp a hose to. And I'm going to order, after I get this mounted, I'll do it later, it won't be on this video, but I'm going to get some, Donaldson makes some big, like 8-inch intake, like rubber intake 90s, like for big trucks. And I should be able to get something to snake it up in here that'll be flexible, that'll let this generator, move on its rubber feet. I somehow failed to mention this is going to be the outlet of the cooling air from the radiator of the generator. Not too sure how well you can see up in here, but all three filters are accessible. There's the, let's see, this is the primary fuel filter. The secondary is right here. I don't know if you can see it. And right here's the oil filter. mess. There's a plate right here that is where you can put the crankcase breather either on the driver's or passenger side of the engine. This plate comes off, and what I'm going to do is pull this plate off, make a new one with a filler spout that comes out to about, you know, right here. It'll have to be pretty tight, you know, maybe 1 inch or something, but still that'll be easy to put a transmission funnel in and pour oil in right here. But it's not done yet, and so we're just going to go inside and pour it in the valve cover. So I'd like to talk a little bit about Detroit engines, and specifically my engine, and some things that I'm doing a little bit differently, and like to give you a little background kind of on myself. I hate people that are like, oh, I've been doing this 50 years, I know everything there is to know, because I know a lot of stupid old people. But I would like to give a little bit of validation to my opinion. And it's just the fact that when I was 18 years old, I took a contract mechanic job as a pretty newbie. I mean, I grew up hanging out with a mechanic, and I knew I was mechanical, but I hadn't had a lot of experience with diesel engines, and certainly with big bores. But I took a contract mechanic job with a oil company. Oil was $150 a barrel or $100 a barrel or something like that. It was high, and I got put in a position that very few people ever get in a job, and I don't mean specifically in the pay, but it was a fact that I got an unlimited reign over everything that they had. 353 cats, 343 cats, of course, you know, 34.6 A's and B's, had a bunch of those, 855 NTC Cummins, and every Detroit you ever dreamed of. I mean, there's, you know, they had everything that existed out there. KTA Cummins. And anyway, I'm pretty resourceful, and the first thing I did when I worked on a lot of that stuff, I went and started buying manuals and stuff for them. I forgot how to do things, and got an opportunity to overhaul several of them. And when I was probably 20 years old, or maybe before I had turned 20, you know, I had built probably, I don't know, a half a dozen or 10 Detroits. There had been 2 Cummins and 2 cats I can think of, two 34.6s. You know, without any supervision. I wasn't just a hand in the shop, you know, that started off scraping grease. You know, I was 19 years old and actually overhauling big bore engines. And so I'm going to be 33 this summer. You know, I'm not that old, but I have had a lot of experience. And like I say, it's not just someone that's working in a mechanic shop with a putty knife scraping grease off an engine. You know, like I say, I was 19 years old and building engines. Now, I'll say all that to give myself a little bit of validation, and I know it probably doesn't matter to any of y'all. But I'd like to talk about Detroit engines and the oil that they use and what people say you need to use. And there's always this big argument. People are big into this. You've got to run 40 weight oil. 15W40 will run Detroits. And I absolutely don't believe that. And I've seen with my own eyes many engines that's run 20 or 30,000 hours with multi-grade oil. When Detroit's first, you know, in the old days of Detroit, they recommended a 40 weight oil, and that's actually what I'm going to run in my generator in this engine. I'll explain why, but this is the only Detroit that I own that'll ever have this in it. So 15W40 versus 40 weight. In the old days, Detroit called for 40 weight. In the late 70s, they changed their recommendation to a 15W40, and then when MTU took back over, they went back to a recommendation of 40 weight. I worked for it was the same company I went to work for. There was a specific rig on there, and the tool pusher liked 40 weight oil. And they had really good luck with it. I'm not saying if you put 40 weight oil in something, it'll ruin it. But we had several engine failures that I tore down, and the bearings looked terrible. And these were relatively well taken care of engines. You know, it wasn't someone that just didn't care, though that's something you see in the oil field a lot. But they would kick bearings out of them. They'd kick rod bearings out of them. And it in my opinion, it's simply because those old Detroits that didn't run a lot of oil pressure, you know, they had 40 or 45 pounds of oil pressure. You know, it's you know, 0 to 30 degrees outside, you know, in a cold winter. You got a hand goes over there and sprays ether in them. They pull the throttle wide open, light them off. They take them to, riv them up when they're cold. And the oil's just so thick you can't get adequate oil flow to the rod bearings, and you melt the babbitt out of them. You just beat the bearings out of them. If you run a 15W40, you don't have that problem because the viscosity under 32 degrees is much, much thinner than a 40 weight. Now, in my opinion, all this 40 weight versus 15W40 argument started back in the 80s and maybe the 70s and the 60s, maybe farther than back. I'm saying pre-80s. And Detroit calls for a low sulfated ash oil. And what that means is when you burn the oil, it's the metallic material that's left in the oil. This is sulfur and zinc and moly and there's a couple more I'm probably forgetting. So those soft metals in a typical engine will actually make the engine last longer in areas where you have metal to metal contact with things like flat tabbet cams in a hot rod. That's why you have to run a high zinc oil in a hot rod with a flat tabbet cam. It's because you have a cam lifter riding on a camshaft, and if it's a hot rod and you've got a bunch of valve lift, you've got a high load there. And if you run something that doesn't have a lot of, today people say zinc, but there's a lot of other metals that work just as well, zinc or moly or sulfur, or there's one more, it's floating around in my head I can't think of. But anyway, that's required in something that has high metal to metal contact pressure. And if you put it in a diesel engine, it'll make those parts last longer, like the rings, whether it hit the cylinder walls or ring glands, if it's got a flat tabbet cam in it, all that kind of stuff, the gear train, it'll make that stuff last longer. The problem with the Detroit is the Detroit not by design, but because of the design, they use a little more oil in a 4-stroke. And what'll happen is you'll have this is a cylinder liner out of a 71, like a 671 straight 6. You'll have oil that'll set down in these edges of these intake ports that comes by the oil glands, the oil rings, and then when the cylinder comes down, the piston comes down. Golly, I'm tongue-tied. When the cylinder comes down, the little small drop of oil will be deposited on or in between the rings. Then when the piston goes up and fires, it burns that oil, and you have that oil that's coked in the ring glands, and this sulfur and zinc and stuff that's left sticks, cements, if you would, the ring gland. Of course, if the ring sticks to the piston, it's detrimental. You've got no compression, and everything goes downhill from there. Now, in the old days, in the 70s and the 80s, Caterpillar Cummins called for a multi-grade 15W40 high sulfated ash oil, usually in about a 1.3 to 1.5% range. And the Detroit called for less than 1%. And I believe that this oil, oils they actually recommended, what Detroit put out was like a 0.8. It was roughly half. And so I think in the old days, a trucker that drove a Detroit, they'd pull into a truck stop and get him a gallon of Dello motor oil, pour it in his Detroit, and 50,000 miles later, the engine won't start, it's got no compression. And they tear it down and all his rings are stuck. And he says, well, that's because I run 15W40 oil, which in my opinion, it had nothing to do with the viscosity of the oil. It had all to do with the sulfated ash, etc. in the oil. Now, I'm going to run a 40 weight oil because I've never seen in practice, and I don't have a scientific measurement of this, but they say, and I've read in studies, that the 40 weight oils will cause a lower oil consumption in a Detroit than a multi-grade oil. Now we're talking, the studies I've seen are usually around 10% reduction. But it's significant. And this engine that's in this coach, the generator, is going to be a worst case scenario for a Detroit, in that it's going to be lightly loaded and it's going to idle for many, many hours. The engine is going to be worn out by idling. And that low temperature of the limited amount of combustion will not burn that oil as well. And so if you have a slight limitation in amount of oil passed by the cylinder by the 40 weight, you know, of 10%, then the engine theoretically should last 10% longer before you have a ring stickage issue. So I'm going to run 40 weight oil, which knocks bearings out of engines, but in my opinion, I think my situation is a little bit different. One, because I don't have a crackhead that's running it for me. And what I have done is I've taken on this engine, and I take on any engine that a customer is hard set on running 40 weight oil, and I shim the oil pressure relief valve and take it from about 60 pounds to about 100 psi. So when you start the engine and the engine has cold oil, it takes 100 psi and shoves that cold oil through the main bearings and through the crankshaft and lubricates the rod bearings better than, you know, at 60 psi, because you just got more flow. But when you get some heat built in the engine and the viscosity of the oil drops, the pressure will come down because the pump output, you know, the volume of the output of the pump can't put up enough pressure, can't put up enough volume to create enough pressure against the bearing leakage. And so the only time that the pressure will be above 60 psi is when the oil is cold. As soon as the oil gets up to temperature, the pressure will begin to drop back to somewhat of a normal level. Also, the other thing that I've done is here's a Detroit injector where you got a fuel in and fuel out, and there's a rocker on it that pushes down on this, and then this is actually what controls the fuel. If you push this in, this one's froze up. You push this in, it would be full fuel. You pull out on it, and it's no fuel. You measure, you set the timing by the height of that injector when it's at full upstroke. And what I've done on this engine is actually added 10 thousandths to that measurement, and so I've retarded the timing slightly. Now, I don't know if this is true, and I could be having this backwards, but in my opinion, what I think of when I do this is with a retarded timing in an engine that's not turning a lot of RPMs, you have the piston up at a higher point in the bore when it injects fuel. This injects fuel directly into the bowl of the piston, and it doesn't give it the ability to spray it out on the cylinder walls. It keeps it in the combustion chamber of the piston. And since the pressure in the cylinder is higher because the piston's higher, you have a more complete burn. And this will make engines start better in the cold. You have a better complete burn, and you have a harder time getting that fuel sprayed on the cylinder walls, and you can't wash the cylinder walls down. And that's, you know, one problem with idling engines is if you get fuel sprayed on the walls, you wash the oil off of them and you gall the liners and the rings. So anyway, my engine is not typically a good place for a Detroit, but I'm running 40 weight oil with higher oil pressure, and I'm running retarded timing with a high compression in engine. And mine is an N. It's not just a 353 non-turbo. It's a 353N, and that N doesn't mean non-turbo or naturally aspirated. With an N engine, you have a higher compression ratio of 21:1 instead of 17:1, and like a 353 or a 353 turbo have got lower compression ratios, and an N has a higher. So anyway, that's what we're doing. Let's go put some oil in it. So I don't really know how much oil this thing's going to hold. I added 3 inches to the oil pan and moved the oil pickup tube back to the bottom of the oil pan. And so there's going to be 3 additional inches of operating room. So the full mark on the dipstick will be correct, but the add mark will be wrong. The add mark will be basically 3 inches too high. Of course, the dipstick isn't that long. I may make another one later, but it'll give me, basically if there's any oil at all on the dipstick, it'll be plenty of oil to run it. It's going to give me a couple extra gallons of room. So let's put it in. I'm going to put 4 gallons in. I actually got a gallon that was leaking. I think it's got 3 quarts in it. Let's put 3 gallons and 3 quarts in it. And well, dang, my funnel won't fit. Let me go find a funnel. All right, the level is right on the low mark, so it probably likes About a gallon, time you figure filling the filter up. So that's 12, 13, about 15 quarts, because that 1 gallon was about a quart low. 15, so 16, 17, 18, 19. It's gonna hold about 19 quarts, 19, 20 quarts, something like that. I think it's ready to try to start. I'm gonna see if we can get it to light. Remember, it's kind of on air because we just switched its fuel supply, or just hooked the fuel supply up to it, rather. This time lapse lasts from 90 seconds after the cold start till 3 minutes and 30 seconds after the cold start. I wanted to make a point and show that in only 3.5 minutes, even on a cold day, the oil temperature rises fast enough to bring the oil pressure back down to what would be considered a standard relief pressure of 60 psi. But that in the first 3.5 minutes of operation, the increased oil pressure to 100 psi helps to push cold oil to the rods and main bearings and any other necessary places that can be starved by the low flow, high viscosity oil. I found it really interesting here. I think the loudest part of the engine is actually the intake. I think I'll have to build some kind of a muffler or intake silencer to put on it. It's really not that loud at all. It's certainly not the quietest generator I've ever heard, but I don't think it's any worse than one in my other motorhome. Of course, that's just an idle too. So over here kind of by the front of the motorhome, just a little bit. Just wanted to make a point here. It's not that bad. It's not near as bad as I thought it'd be. I'm gonna put this this little storage compartment door right here, because there's the belts that you got to get to on the front of the generator, and about the only way you'll be able to do them is through this, unless you take the bed off. I can get to all the belts. So everything looks pretty good. It's got one oil leak on the back of the big alternator here that's on the side, but it'll be easy to get to and fix from out here. I want to skip forward a little bit in this video. I want to go in and finish enough of the plumbing that we can turn the hot water heater on. I'm going to put the plywood on top of this to where you can't access it from the inside anymore, so I can finish the plumbing. And then I want to load it up and put as much load as I can on it, like turn on all 3 air conditioners and a couple of heaters and the instant hot water heater, etc. And we'll see how it acts. We'll catch you here in a few days. Alright, I'm going to light the generator, build some heat in it, take it to gen mode. I've got the instant electric hot water heater and all that stuff hooked up, and we're going to start putting load on it. I'll kind of voice over the load as we go. At this point, I've got two 1500 watt electric heaters running, a 2000 watt 6 gallon electric water heater, 2 air conditioners, and you just flat came here it loaded up at all. You can just catch a glimpse of the third air conditioner starting, and then shortly after that I turn on the 13,000 watt electric instant hot water heater. You can hear it kind of loaded up a little. So it's still running. I wanted to give you an idea how loud it is in here. It's pretty noisy. I don't have the insulation over the generator part, and it's going to have a mattress that goes over that. I think that'll help significantly. Most of the sound is in the bedroom, and I don't plan on ever having to run this thing while I'm trying to sleep. I've got a big battery bank that should be good for 8 or 10 hours. And I think during the day, if you were to shut the bedroom door, along with the extra insulation and the mattress over the top of everything, I don't think it'll be bad. I think you'll be able to hear it. I know this is purely an opinion, but to me, an engine like that isn't nearly as annoying at the same decibel level as a single lung Briggs & Stratton, you know, engine with a muffler about that big, you know. They're not as bothersome to me. You know, that right now it's probably about as loud as, I don't know. I mean, if you had a TV in here at normal level, you could hear it pretty well. You know, you might have to turn it up a notch or two. And like I say, once we get all the insulation in, I don't think it'll be bad at all. We run it about almost 45 minutes with a 13 kilowatt instant water heater, plus probably another 10,000 watts. We're probably running about 23,000 watts, something like that. I didn't have an amp meter, I couldn't check it, but it was two 1,500 watt electric heaters, 2,000 watt water heater, and then all 3 air conditioners were on high with the compressors running, and some various, you know, lights and some other things. So I mean, we had a pretty good load on it. The engine got up to about 200 with the door shut, 205, something like that, and opened the door, and it didn't really go up or down. But you got to remember, there wasn't any air circulation. It was just pulling the same air through the radiator as it was blowing through it. You know, it's just circulating the cooling air. I got to get that boot I talked about the other day where it blows the air out that grill. I guess that's about it. I hope you learned something. I hope you enjoyed watching, or I don't know why the heck anybody watches, but I appreciate it. I guess we'll catch you here in a week or two.